OK, so I work for the UK government. I work, as John said, on the gov.uk website. If you want to know anything about how UK government works or what services are available to you as a citizen or a business, you don't have to go to the individual government departments. You just go to gov.uk. It gets about 5 to 6 million hits a day, and it runs on about 80 servers. And it's hosted by a company called Skyscape. And Skyscape's cloud infrastructure is VMware's vCloud Director. And about a year ago, we wanted to move to a new vCloud Director environment platform. And we looked around for some tools to automate provisioning of that new environment, but we couldn't find any. So we built some. So I'm going to tell you a bit more about working for the UK government, a bit more about what we do. I'm going to tell you how we did infrastructure as code on the gov.uk website. And then I'm going to share with you 3 things I learned working on this project. So my name's Anna Shipman. I'm a senior developer. I work on the infrastructure team that supports gov.uk. So I'll tell you a bit more about the department I work in, which is the Government Digital Service. It's a unit of government. You heard this morning about the US Digital Service. What Mikey didn't mention, probably because he didn't have time, is because you guys totally copied us. So our job, DDS's job, is to transform government. No big deal, nothing major. First thing we did was the gov.uk website, single domain for government. I'm going to tell you a little bit more about the work that GDS is doing apart from gov.uk, because it's quite interesting. We're transforming government services. We're moving them from paper-based to digital by default. And the aim is to make government services, make the digital channel so good that people prefer to use that rather than phoning up a call center or going into an office. So I'm going to tell you what I mean by give you some examples of public services that we're transforming. The first one is individual electoral registration. So until this project was launched, the way you registered to vote in the UK was a letter would go out to the head of the household. So usually that's the father. And that would list all the people eligible to vote or around the age of 18 or over in the household. And the head of the household would fill that form in and send it back to confirm that all those people were eligible to vote. So that means if I still lived at home, my dad would get to decide for me. What this project did was, firstly, we made it digital. So you register online. It's not a letter that gets sent to your house anymore. And also, it's individual. I get to vote. I get to decide myself. I get to fill in myself whether I'm eligible to vote. So this is, when the project was launched earlier this year, we migrated 47 million users. Just to put that in context, that's everyone in the UK who's eligible to vote. And since it was launched, we've had 1.5 new applications. But to change the way that this worked, to make it individual rather than head of the household, we actually had to change legislation. We made a fundamental change to the way that democracy works in the UK. So it's pretty big stuff we're involved in, not just digital. I want to give you another example of a public service, which is on a slightly smaller scale, but another example of the kind of thing we do, which is carers allowance. So in the UK, if you spend 35 hours or more a week caring for somebody, so that might be looking after a disabled child or caring for an elderly relative, then you're eligible for some money from the government to support you in that. And again, the way that you used to claim for that was by filling in a very long form. It took about 45 minutes to fill the form in. And there were some pretty difficult questions. And as part of moving this online, the team working on it looked at the questions you needed to be asked. And they found that a lot of those questions, we didn't need that information. So we were able to reduce the number of questions asked by a third. And we were able to reduce the average time it took to fill that form in from 45 minutes to 20 minutes, which is quite a big deal, because the chances are, you don't ever want to find yourself in that position, filling in a form to claim money from the government to do something that might be quite emotionally very difficult. So anything we can do to make that less painful is really good. And this service has received 89% user satisfaction, which is amazing for a government service. So GDS has taken on a task of transforming 25 of the biggest services in this way, making them digital by default. It's not just GDS, like our colleagues in other departments in government are also doing work on this. And if you're interested in in learning more about this, my colleague Cal Beer is doing a talk right after this at 3:30, which is really good, so you should go and see that. At GDS, we work in open, agile, multidisciplinary teams. I'll talk a little bit more about those things later. And we focus on user needs. So the first thing we look at when bringing up a new project is what are the user needs. That's actually the first of our design principles. We have these 10 design principles that guide all the projects we work on. And to some of you, this may look slightly familiar because the US Digital Service have their digital service plays, which also are totally copied from our design principles. OK, so that's a bit about the UK government. Now I'm going to tell you about how we did infrastructure as code in this project. So you can imagine this is a pretty interesting environment to work in. You know, we have a mandate for change. We can even change the democratic process. But we're still government. We're still subject to the same kind of constraints that is natural for government. So I'll give you an example. We now have a cloud-first policy, which means that whenever we're looking at hosting a new project, we need to first look at whether it can be hosted in the cloud rather than a cabinet we might have in the office or a government data center or whatever. But we're still government. So it's still high profile, so we're under a lot of scrutiny. We have to be very security conscious because it's serious data, serious information that we're handling. And government is traditionally very risk averse. So what this means is when we're buying technology, it's not just the technical aspects of it that we need to think about. There's other things we have to take into account. It has to be security assured to a certain level. And everything we buy has to be part of a purchasing framework. So buying things in government we call procurement. And I won't go into the details of how you buy things from this purchasing framework, but it's really arduous. Like, there's a lot of steps involved. And the reason is, these are all checks and balances to make sure that we spend public money fairly. It's really important that the way that, the technology we buy is not like, my friend, that I know it's good. It has to be, obviously, it has to be very, very clearly distributed in a fair way. And this does mean the process is quite difficult. So the GovUK website in beta was hosted on Amazon Web Services because in beta, you're not subject to those kind of constraints. You can just buy whatever's easiest on your credit card. Somebody paid for it on their credit card. But when we went live, we had to go through this procurement process. And after we put in all our requirements and gone through the process, the supplier we selected was called Skyscape, as I mentioned, and their cloud infrastructure is VMware's vCloud Director. So out of the box, oh, sorry, this is my enterprise diagram. I don't know why I drew that. So out of the box, vCloud Director gives you a Flash UI for configuring new machines. I couldn't make it bigger because it's Flash. So you click new VM. This is for networks and everything, but this is like for configuring a new VM. You click new, you choose the template, you select the size, you hit go, and then you wait for it to come up. So, I mean, that's slightly subject to error. You might hit the wrong button. And ideally, we want our infrastructure saved as code. We want our configuration to be reliable, to be repeatable, to be automatable. When the beta was hosted on AWS, we had scripts to spin up machines. And when we chose our new environment, we had quite a tight deadline. So we basically just hacked our AWS scripts until they worked with vCloud and called it done. Which is fine. Sometimes, well, the strategy is delivery, as our CEO is very fond of saying. And sometimes the best way to do something is the quickest, not necessarily the most elegant. But there were a few problems with the tools that existed then, this de facto tool that we used to bring up machines. It was pretty slow. So last year, we had a new app. I had to bring up 3 machines. So 3 in preview, 3 in staging, 3 in production. So 9 machines. And to bring up those 9 machines took 2 days. That's not ideal. I wasn't working on it for 2 days. It was lots of scripts running in the background, but it was pretty slow. Other than that, there were bugs, there were high error rates. Sometimes it would take 3 or 4 times to launch a machine. But also, as I kind of hinted earlier, it had details of our environment hard-coded into it. And this became a problem for us because Skyscape launched a new platform that had more features than our existing one, and we wanted to migrate to it, but we were locked into the previous one. So we looked around. This was about a year ago that we started this project. So actually something called Terraform was launched. I don't know if any of you have heard of it. That was, yeah. So that was announced about a month ago. That looks really awesome. I think we would have looked more at that, but this was a year ago, and we looked around and we couldn't find anything at all that did what we needed it to do. So instead of hacking our scripts again, we decided to form a small team and do it right this time. What's my next slide? Oh, yeah. OK, so vCloud Director supports the vCloud API, which is a RESTful API. You write XML to interact with it. And so we don't have to write XML. We use an open source Ruby service library called FOG, Cloud Services Library, an open source Ruby library called FOG. And what we built was a suite of tools called vCloud Tools. Now, the easiest way to explain, to take you through what each of the tools are, is if I tell you how we used them in March to migrate to the new platform. So first, we use vCloud Walker. You give vCloud Walker the details of your environment, the credentials, and it walks it and gives you an output in JSON or YAML showing what's in your environment, so the networks, the firewall configuration, what machines, how big they are. And then using that configuration, we created network configuration. We used vCloud Net Launcher to launch the networks. We used vCloud Launcher to launch the virtual machines. And finally, we used vCloud Edge Gateway to launch the vShield Edge, which is VMware, vCloud Director's way of dealing with firewalls, NATing, load balancing. For the migration, we use these tools to bring up 150 machines, 14 networks, and dozens of VSE rules. That's just to show you that it's not like a toy thing. Like, we did a lot of stuff with it. The configuration file is in JSON or YAML. So this is the config for the little animation I showed you. That's the config for the same machine. And then you call it like this on the command line or in a script. And the new tools are, they're much more maintainable. They've got 84 to 99% coverage. I say 84 to 99 because one tool has 84% unit test coverage, and all the others have 99%. They run integration tests. The integration tests spin up machines and networks in a live environment. And it's open source. I'm going to talk a little bit more about that later. OK, so that's that with the tools we built. And now I want to tell you 3 things I learned on this project. So the first thing I learned was, my slide. You need web operation skills and development skills to do infrastructure as code. You need people who know about infrastructure, and you need people who know about code. But it sounds maybe kind of obvious, but it isn't always. And I'll tell you how I learned this revolutionary fact. So when I joined the project, a team of 3 web ops had been working on it for about a month. And they'd been doing a really good job. They'd been adding unit tests, pulling out the configuration, stuff like that. But they'd asked for a developer to help them because they were struggling with some of the architecture aspects of it. And when I joined the project, it was pretty clear to me straight away that it was too tightly coupled. So they had, at that stage, they had one repository which was vCloud Walker, pretty similar to what it is now. And then they had another one, which was vCloud Tools. And vCloud Tools did everything else, everything that you might want to do with vCloud. Launching machines, networks, all the interactions with FOG and the vCloud API were scattered about all over the place. So I preferred a more kind of Unix-y architecture, so I refactored it. Now it looks like this. So there's one gem, vCloud Core, and that takes care of the interaction with FOG and the vCloud API. The other 4 gems I mentioned all depend on vCloud Core for their interaction. And each one does a particular job. And then this other one, vCloud Tools Tester, is one we just use in development for helping us with our integration tests. So actually, I want to tell you how I did this, because this is kind of cool. So the way I did this refactoring was I made a local copy of vCloud Tools. And then I used git filter branch. Yes, then I used git filter branch to rewrite history so that nothing unrelated to vCloud Launcher had ever happened. And then I had a new vCloud Launcher gem, and I pushed that up. Sorry. And then I deleted what vCloud launched from vCloud Tools, and I did that for each of the gems. Anyway, I've written a blog post about that. There's a link at the end. I thought it was quite cool. So OK, so that's the new architecture. So there are a couple of advantages with this the way it's architected now. It makes it easier to tell a story about it, like I did earlier, to explain to you how they work. It makes it obvious where code should go. So when I joined the project, we had a lot of discussions about where a new feature lived. But we don't have those discussions anymore. It's pretty obvious where it needs to go. And it means that multiple people can work on it at the same time. So it's not totally perfect. We do get sometimes involved in dependency hell when we want to upgrade something and something else has to. It depends on that. But the main problem with this architecture was the time it took me to refactor it. I was a bit of a bottleneck while that was going on. You can't add new features to vCloud Launcher if it's in the process of being moved from A to B. So it would have been easier if we'd had that architecture from the beginning. Which is kind of a banal point, like obviously you don't always know how things are going to work out and you do need to iterate things. But it was clear to me as soon as I joined the project, because of my background in development, like I'm familiar with this kind of architecture. So this is why I'm saying you need developers and web ops on the teams. You need people who have experience of that kind of thing if you're going to do a proper infrastructure as code. I'm not coming here to be like an asshole developer and be like, yeah, you always need developers. Developers make everything better. I mean, there's no way developers could have done this project without web operations engineers. I could list the things that they explained to me how to do. It would take a long time. They knew, they were brilliant. What I'm trying to say is that you need both kinds of people. It kind of links back to what I was saying at the beginning that we do at GDS. About having multidisciplinary teams. You have subject matter experts, and you have people who are expert in different areas. And that's how you build a really good product. I'm going to summarize this point. Hashtag DevOps. OK, thanks. Right, moving on. So the second thing I learned, and this is the main thing that I took away from this and I've used on subsequent projects, is make sure that you understand the context. When you join a team, you're in a unique position to make sure that you really understand every decision that's been made. So I'll give you an example of this as well. On a project like this, you have to make trade-offs. And one of the trade-offs we made, this emerged quite early on, was it emerged that we were writing a lot of code in vCloud Core, or rather what was later to become vCloud Core, that maybe more properly belonged in Fog. So we made a decision to carry on that path and write the code in vCloud Core and not contribute it back to Fog at that point for two reasons. One is we had a deadline to migrate to the new platform, and we weren't sure we could fit into Fog's release cycle, waiting for pull requests to be merged and a new version to be released. But the other reason was that when you contribute code to Fog, whenever you contribute a real call to the API, you also need to contribute a mock call to the API. And writing the mocks was really difficult. It was too difficult. Yeah. And so we made a decision not to do it at that point, but later to work on it after we'd met our deadline. And my architecture mitigated that because that code is all in vCloud Core. So we can, and we have started doing now, move it back into Fog, and the calling gems don't, they're none the wiser. The interface remains the same. So a couple of months ago, I decided to try adding mocks to Fog to see why it was so hard, which I hadn't done at the time. And it turned out it wasn't that difficult. And that's not because they were wrong. It's because the way that you added mocks to Fog changed in October last year. And it became much easier. So this was just before I joined the project, but after they'd already investigated how to do it. So if I had, at the time, if I'd actually tried, they said it's too hard. If I'd gone away and tried to do it, I would have discovered something that could have moved the project forward. It would have been handy to have mocks in Fog, because if you can run Fog in mock mode, firstly, you can run it without having access to a vCloud Director environment, which is quite handy. And secondly, they run really quickly. Like, our integration tests take about 10 minutes to run, which is too long for sort of regular development. You do it at the end. If we could run them quickly like unit tests, we would have been able to use them more. So you don't want to be the annoying person who turns up on the team and like challenges every decision they've made. I'm not suggesting you do that. But what I'm saying is you should do your homework. You know, what I could have done is, you know, not necessarily challenged them, but just gone away and made sure I understood that by adding some code myself, some mocks myself. So that's something important that I learned. I had a little bit more to add here. Does anyone work for VMware? No. OK. Because the documentation of the API is excellent. It's really good. But there are a couple of gaps. And my team asked me to ask if anyone on VMware watched the video, if they could open source the documentation so we could make some pull requests to make some changes. Because a lot of the doing your homework involves going through that. In general, it's very good, though, so if you're thinking of using it. Oh, and this slide is just to remind me just to be clear, like, we have started adding the code back to Fog. We haven't just been like totally parasitical and written all this stuff and not contributed back. One of the people who was on the team then is now like, he's not a core committer, but he reviews all vCloud Director pull requests to Fog. So we're not just parasitical. OK, which brings me to the third thing I want to share with you that I learned working on this project, which is make things open. It makes them better. This is actually our 10th design principle. I'd written it differently, and then I realized it mapped pretty much exactly onto our 10th design principle, and it's number 13 of the US Digital Services design principle. At GDS, we have this concept of coding in the open. So pretty much everything on GovUK, all of the apps on GovUK are open source on our AlphaGov organization on github.com. There's almost everything. There's one or two sensitive projects, and then some stuff like credentials. But pretty much everything else, like 50 apps involved in GovUK, are available on AlphaGov. But we say this is coding in the open rather than open source for two reasons. One is we don't necessarily expect it to work in your environment without the rest of our setup. And also, we're not committing to supporting it long term. You know, if we decide our publishing tool is not going to work for us, we'll retire it and build a new one. But the code is all open, and you're welcome to go and have a look at it and use it if it's useful to you. As well as coding in the open, we do have supported open source software. And at the moment, that's all operations related. So it's in our GDS operations organization on github.com. vCloud tools are there. There's a lot of Puppet modules. There's Unicorn Herder, which is pretty cool. Check it out. And we do expect that to work in your environment. If it doesn't, you can let us know, and we'll take a look. And also, we are committing to supporting it long term. But the reason making things open in this project helped us is because when you code in the open, it forces you to do things right to begin with. It forces you to like separate code from configuration. So right from the start on vCloud tools, we couldn't go down the same path that we went down with the previous tools, because you know when it's out there on GitHub.com, you know you're extra careful about not committing details of your environment and to making sure that the configuration is something you can save separately. Not just separating code from configuration. Another way it helps is by making you consider how your project will work for other people who might be using it. So, for example, the previous tool that I talked about that we used, it had hard-coded in it that you had to use a Puppet Master. And it's a bit embarrassing. Like, if we're making that open source, we're saying you can only use this if you use Puppet Master. So shame is a big motivator for helping with that. The other advantage of making things open source is that you get very early users. So some of the gems some of our vCloud tools aren't yet at version 1.0, so we wouldn't necessarily have published them. But because it's open source, people started using them. And this has been really handy. So I'll give you two examples of how early users helped us. One is we don't use sticky sessions on GovUK. Every request is new. But the tools did support persistence, or said they did. But then somebody trying to use them raised this bug that it didn't support persistence. And what it turned out was actually we validate your configuration before sending it to the API so you can fail fast. And we'd left out the bit where we validate persistence. So the code was there to set up persistence, but your configuration would never make it. So it's just a one-line fix, but we would never have noticed that ourselves because we don't use persistence. Another example was this one, which we're quite excited about because this is someone who none of us know, who doesn't work in government, who found vCloud tools by Googling and started using them. So this was pretty exciting when we saw this, and all those retweets and favorites are my colleagues. This is a publishing company, and I went to have a chat to them about how they used them. And again, they added, so not even raising a bug, they added support for IP pools. So we allocate by DHCP or manual. And again, we don't use IP pools. So we could have added the support, but it would have been pretty difficult for us to test it. But they did that for us. So that was great. It's not unmitigated joy. There are difficulties having early users and supporting open source software, and that is like a whole nother talk, and I'd be really happy to discuss that if anyone wants to come and talk about that later, but I don't have time right now. In general, on balance, the benefits outweigh the disbenefits. It's great. If you can do it, do. OK, I think, yes. So, sorry, I can't see my next slide. So, the Velocity people told me to finish with a call to action, which is handy because I do have a call to action, which is get involved. So contribute to vCloud tools. We'd love you to contribute to vCloud tools. That would be fantastic. And if you're not that interested in vCloud Director, we have a label, newcomer friendly, which is issues that don't involve an in-depth understanding of it, don't involve access to a vCloud Director environment. So if you're not that interested in vCloud Director, but you want to get involved in contributing to open source, this is a nice, easy way to do it, and we'll be nice to you. Maybe not vCloud tools, but think about contributing to one of the other open source projects I've mentioned, Fog or Terraform. They're both really useful. They have issues. They could use your help. But the main call to action I have, the main way I think you should get involved, and we've already heard this today, is go and work for government. Like I've told you, well, Mikey talked about some of the interesting challenges you have here. I've told you some of the ways that you can get involved, changing democracy, or just improving people's lives in a small way. It's really great. So go, if you're American, go and work for the US Digital Service. If you're British, please come and work for the Government Digital Service, or whatever your government is. Go and work for government and make things better. Thank you. I've got 5 minutes if anyone wants to ask any questions.
So I'm been a big fan of your project and a lot of people on the team, and you really did get some just quality people from a DevOps perspective, which is amazing. So the one thing, it seemed like most of the discussion was really more about provisioning, configuration.
Yeah.
What do you do after the host is configured? Do you want to elaborate a little bit? Did you write that stuff yourself, or did you check a Puppet?
Oh, OK. So the question is, this is mostly about provisioning. What about post-provisioning? Yeah, we use Puppet. Yeah. And our Puppet repository is actually is closed source at the moment because it's got too many details. But we have a story in our backlog to try and make that open source as well to move some of that stuff out. But yeah, we use Puppet. Sure.
It sounds like you came in as a development, so it was primarily an operations team.
Yeah.
In terms of the distribution of skills, do you think it's better to have pure developer resources working alongside operations staff, or to try to look for operations people who train them in some of the development tools and techniques in order to get the DevOps team? What do you think is the best distribution?
As in, what were the alternatives?
So the alternative would be to take people who are primarily Linux sysadmins or primarily developers and train them.
Oh, as in. Oh, so the question is whether it's better to have developers and web ops, or whether it's to train developers in web operations and train web ops in development. I mean, I think, so both are good, I think. What we have at the moment on our infrastructure team is we've got a range. So I'm a developer, and I know some web ops now because I've been on the team for about a year. But I've mostly been involved in development. And then we have, at the other end, we have hardcore sysadmins who don't really want to get involved in coding, but they know what they're doing and they're really experienced. And then we've got a range of people in the middle. So we've got some people who have come from either one of those backgrounds and have learned the skills. And I think that's a really good, it's good to have that kind of range. I don't think you should try and force people into, into doing something that they don't want to do.
Yeah, the assumption was there'd be willingness to learn
Yeah.
by cases.
Yeah, but I mean the two people I'm thinking of who are like hardcore sysadmins, they're absolutely brilliant. They're invaluable to the team, but they're just not that interested in coding, and that's fine.
Great, thank you.
Sure.
I was just wondering about the structure of your team or teams. Do you have teams that come and go with projects, or is it one larger team? What's the structure?
So on GovUK, so the question was, what's the structure of the teams? Do we have set teams, or do they come and go? Both. On GovUK, we have some sort of long-running teams. So, for example, Search and Browse is a long-running team because there's a lot of government information. It's really important how you navigate that. But then we have spin-up teams, sometimes for 6 weeks to do a short-term thing or for a shorter period. The GovUK infrastructure team is pretty stable, but then the product teams mostly come and go. Yes?
So do you have team managers or leaders? Like how does a team lead or a team manager, how do you all structure that?
Okay, so the question was, do we have team leaders, team managers? Yeah, mostly we do a kind of roughly Scrum methodology. So we have a product owner, a delivery manager, and then the rest of the team. And then on a product team, the rest of the team might be developers, front-end, back-end, user researchers, quality. That's what we mean about a multidisciplinary team. It might be a variety of roles. There might be a web operations person on the team temporarily or long-term. On the infrastructure team, we have a product owner and delivery manager as well. Sure.
So do you use your same software development project management methodology for your DevOps systems as well? Like, you treat those as a project?
How do you mean?
Like, do you treat your back-end systems development
Ah.
treat your front-end systems?
So do we treat like infrastructure as a project in the same way that we have product teams working on front-endy projects? Not really, not exactly. I mean, so this vCloud Tools team we span up a team and we had, we did treat it as a product. The team came together, did the work, and has now gone on to other things. But for the infrastructure team, we have a pretty set GovUK infrastructure team, and so we work on a lot of things at once. So we might have one priority, but we don't actually specifically spin up a project to work on that. But we're sort of looking at that kind of thing as well, because we find that sometimes we have a lot of stuff in play, and it would be good to do that, to like focus on something. Anything else? Okay, early break. Thanks.